We have a point in space. How many lines can be drawn through it? There would be infinitely many lines that would pass through it. But if we have 2 points, we know that a unique line would pass through them. Similarly, if we know that the line passing through that point has a slope m, then also a unique line can be located. Slope is equal to m. Once the line has been exactly located, its equation can be found. Let us find the equation of a line whose gradient and one point are known. Suppose we have a point a, 1, 1, and a line with gradient is equal to 3 passes through it. If bxy stands for any point on that line, the gradient of AB must also be equal to 3. MAP is equal to y2 minus y1 upon x2 minus x1. Therefore, 3 is equal to y minus 1 upon x minus 1. Therefore, 3 into x minus 1 is equal to y minus 1. Therefore, 3x minus 3 is equal to y minus 1. Therefore, 3x minus y is equal to 2. This is the equation of all the points on the line. The equation of the line passing through a given point x1, y1 and gradient m is equal to y minus y1 upon x minus x1. Or y minus y1 is equal to m into x minus x1. A wire between two poles has a slope of 2. One of the endpoints is a, 1, 5. The other is b, x, y. Find the equation of the wire. Equation of a line with slope m and passing through a point x1, y1 is y minus y1 is equal to m into x minus x1. Here, x1 is equal to 1, y1 is equal to 5, m is equal to 2. Hence, y minus 5 is equal to 2 into x minus 1. Therefore, y minus 5 is equal to 2x minus 2. Therefore, 2x minus y is equal to minus 3. The equation of the line is 2x minus y is equal to minus 3. Different forms of ax plus by plus c is equal to 0. The various forms of the equation of a line that is reduced from the general equation of a line are as follows. A. Slope-intercept form. If b is not equal to 0, then ax plus by plus c is equal to 0 can be written as ax plus by plus c is equal to 0. Therefore, by upon b is equal to minus ax upon b minus c by b, dividing by b on both the sides. Therefore, y is equal to minus ax upon b minus c by b. On comparing it with y is equal to mx plus c, we get m is equal to minus a upon b and minus c upon b. Hence, we can say that y is equal to mx plus c is the slope-intercept form of the equation of a line whose slope is minus a upon b and y-intercept is minus c by b. If y is equal to mx plus c is a vertical line, then b is equal to 0, whose slope is undefined and x-intercept minus c by a. Intercept form. If b is not equal to 0, then ax plus by plus c is equal to 0 can be written as ax plus by plus c is equal to 0. Therefore, ax upon minus c plus by upon minus c is equal to minus c upon minus c, dividing by minus c on both the sides. Therefore, x upon minus c upon a plus y upon minus c upon b is equal to minus c upon minus c. X upon a plus y upon b is equal to 1. Hence, x upon a plus y upon b is equal to 1 is intercept form of the equation of a line whose x-intercept is minus c by a and y-intercept is minus c by b. Normal form. We know that x cos omega plus y sin omega is equal to p, the normal form of the line. We represent it by the equation ax plus by plus c is equal to 0. On comparing x cos omega plus y sin omega is equal to p, then ax plus by is equal to minus c. We can say that a upon cos omega is equal to b upon sin omega is equal to minus c upon p. Therefore, a upon cos omega is equal to minus c upon p. b upon sin omega is equal to minus c upon p. Cos omega is equal to minus ap upon c. Sin omega is equal to minus bp upon c. We know that sin square omega plus cos square omega is equal to 1. Therefore, minus bp upon c the whole square plus minus ap upon c the whole square is equal to 1. Therefore, b square p square upon c square plus a square p square upon c square is equal to 1. Therefore, p square into a square plus b square upon c square is equal to 1. Therefore, p square is equal to c square upon a square plus b square. Therefore, p is equal to plus or minus c upon root a square plus b square, taking square root on both the sides. Putting the value p in cos omega and sin omega, we get cos omega is equal to minus a into plus or minus c upon root a square plus b square upon c, which is equal to plus or minus a upon root a square plus b square. Similarly, sin omega is equal to minus b into plus or minus c upon root a square plus b square upon c is equal to plus or minus b upon root a square plus b square. Example: equation of a line is 2x minus 5y plus 12 is equal to 0. Find its slope, x and y intercepts. Solution: the given equation 2x minus 5y plus 12 is equal to 0 can be written as y is equal to mx plus c. Therefore, 2x minus 5y plus 12 is equal to 0. Therefore, 5y is equal to 2x plus 12. Therefore, y is equal to 2x upon 5 plus 12 by 5. Comparing with y is equal to mx plus c, we have slope of the given line as m is equal to 2 by 5. The given equation 2x minus 5y plus 12 is equal to 0 can be written as x upon a plus y upon b is equal to 1 form. Therefore, minus 2x plus 5y is equal to 12. Therefore, minus 2x upon 12 plus 5y upon 12 is equal to 12 upon 12, dividing by 12 on both the sides. Therefore, x upon 12 upon 2 plus y upon 12 upon 5 is equal to 1. On comparing with x upon a plus y upon b is equal to 1, we get a is equal to minus 12 upon 2 is equal to minus 6 and b is equal to 12 upon 5.
Example: reduce the equation x plus y minus 10 equals 0 into normal form. Find the values of p and omega. Solution: we know that the normal form of the equation ax plus by plus c equals 0 is x cos omega plus y sin omega equals p, where cos omega equals plus minus a by square root of a square plus b square, sin omega equals plus minus b by square root of a square plus b square, and p equals plus minus c by square root of a square plus b square. Here a equals 1, b equals 1, and c equals minus 10. Cos omega equals a by square root of a square plus b square. Sin omega equals b by square root of a square plus b square. P equals c by square root of a square plus b square. Therefore, cos omega equals 1 by square root of 1 plus 1. Sin omega equals 1 by square root of 1 plus 1. P equals minus 10 by square root of 1 plus 1. Therefore, cos omega equals 1 by square root of 2, sin omega equals 1 by square root 2, and p equals minus 10 by square root 2. Therefore, 1 by root 2x plus 1 by root 2y minus minus 10 by root 2 equals 0. X cos 45 degrees plus y sin 45 degrees minus 10 by root 2 equals 0. Hence, omega equals 45 degrees.
Find the angles between the lines 3x plus y minus 10 is equal to 0 and y minus 2x plus 20 is equal to 0. The two lines given here can be written as y is equal to minus 3x plus 10. Mark this equation as 1. And y is equal to 2x minus 20. Mark this equation as 2. Comparing the lines 1 and 2, with y is equal to mx plus c, we get slope of the line 1, m1 is equal to minus 3 and slope of the line 2, m2 is equal to 2. Hence, the angle between the two lines can be found out by the formula tan theta is equal to modulus of m1 minus m2 whole upon 1 plus m1 into m2. Therefore, tan theta is equal to modulus of minus 3 minus 2 whole upon 1 plus minus 3 into 2. Therefore, tan theta is equal to modulus of minus 5 upon minus 5. Therefore, tan theta is equal to modulus of 1. Therefore, theta is equal to tan inverse of 1. Therefore, tan theta is equal to 45 degrees. Hence, the angle between the two lines is either 45 degrees or 180 degrees minus 45 degrees, which is equal to 135 degrees. Show that two lines P1x plus Q1y plus R1 is equal to 0 and P2x plus Q2y plus R2 is equal to 0, where Q1 and Q2 are not equal to 0 are 1. Parallel if P1 upon Q1 is equal to P2 upon Q2, and 2. Perpendicular if P1 P2 plus Q1 Q2 is equal to 0. The given lines can be written as P1x plus Q1y plus R1 is equal to 0, or Q1y is equal to minus P1x minus R1. Therefore, y is equal to minus P1 upon Q1 x minus R1 upon Q1. Mark this equation as 1. P2x plus Q2y plus R2 is equal to 0. Therefore, Q2y is equal to minus P2x minus R2. Therefore, y is equal to minus P2 upon Q2 x minus R2 upon Q2. Mark this equation as 2. On comparing equations 1 and 2 with y is equal to mx plus c, we get slope of the line 1, m1 equal to minus P1 upon Q1, and mark this equation as 3. Similarly, slope of the line 2, m2 is equal to minus P2 upon Q2. Mark this equation as 4. Let us solve the first part of the question. Now, by the given condition 1, we have P1 upon Q1 is equal to P2 upon Q2. Multiplying both the sides by minus 1, we get minus P1 upon Q1 equal to minus P2 upon Q2. Therefore, by 3 and 4, M1 is equal to M2. Hence, we can say that the lines are parallel as M1 is equal to M2, that is, their slopes are equal. Let us solve the second part of the question. Now, using the given condition 2, we have P1 P2 plus Q1 Q2 is equal to 0. Therefore, P1 P2 is equal to minus Q1 Q2, that is, P1 upon Q1 is equal to minus 1 upon P2 upon Q2. Therefore, by 3 and 4, M1 is equal to minus 1 upon M2. Therefore, M1 M2 is equal to minus 1. Hence, the lines P1x plus Q1y plus R1 is equal to 0 and P2x plus Q2y plus R2 is equal to 0 are perpendicular as the product of their slopes equal minus 1.
Example. Find the equation of a line perpendicular to the line 2x minus 5y plus 6 is equal to 0 and passing through the point 75. Solution. We can write the given line in the form of y is equal to mx plus c. 2x minus 5y plus 6 is equal to 0. Therefore, 5y is equal to 2x plus 6. Therefore, y is equal to 2 by 5x plus 6 by 5. On comparing line 1 with y is equal to mx plus c, we get slope of line 1, m1, is equal to 2 by 5. Therefore, slope of line perpendicular to line 1 is m1 m2 is equal to minus 1. m2 is equal to minus 1 upon m1 is equal to minus 1 upon 2 by 5 is equal to minus 5 by 2. Therefore, m2 is equal to minus 5 by 2. The equation of a line passing through point P x1 y1 and with slope m is given by y minus y1 is equal to m into x minus x1. Here, m is equal to minus 5 by 2 and 7 phi is equal to x1 y1. Y minus y1 is equal to m into x minus x1. Therefore, y minus 5 is equal to minus 5 by 2 into x minus 7. Therefore, 2y minus 10 is equal to minus 5x plus 35. Therefore, 5x plus 2y minus 45 is equal to 0. Hence, the required equation of the line is 5x plus 2y minus 45 is equal to 0.